Alright, this is how this could look like. We have the kitchen environment, and I'm using a behavior tree framework using the PyTrees library. I'm using sequences, parallel, and selector nodes from them. And this looks like this. My tree consists of a sequence which I call main. And the first thing it does, it goes into the selector, which I named does the map exist. And in the selector, the first node is a node called does map exist, which tests for the map. And if that fails, it goes into this parallel node, which executes the mapping and navigation behavior in parallel. And once this is done, I go into planning mode and plan a path to the lower left corner. The robot then drives there using the navigation behavior. Then I plan another path to the sink and the robot goes there. So when we start this looks as follows. The robot outputs map doesn't exist and then executes a waypoint consisting of 16 values. The waypoints are defined here. These are the waypoints that we've been using previously. I now concatenate them with this 8 waypoints going forth and then another 8 waypoints going back, for which I flip the array. And I write those to a blackboard data structure. The blackboard I created myself. I chose not to use the blackboard provided by the PyTrees library. All it does is it initializes a dictionary data, and then I have the opportunity to write key value pairs into this data structure and read from it. Now you can see that each of my nodes is actually using a link to the blackboard, and this is how I can exchange data between the planning and the navigation node. I also write the robot handle, which is the Webots robot data structure, to the blackboard, so each of the behavior tree nodes can actually access the robot's sensors and actuators. Now the robot is going around. I can speed this up a little bit, and as soon as it has completed its circle, this behavior finishes, which will also terminate the mapping behavior. And the way I've done this in PyTrees is I set a policy called success on one, which means that the parallel node is successful if one of the nodes therein is successful. There are many other options, and this really depends on the library you're using or on how you implement this yourself. In this case, this made sense. As soon as navigation is complete, the mapping node also terminates. So now the robot has planned a path which goes from where it started to the lower left corner, and now you see I generated 169 waypoints to follow. Now let's go into the mapping node. The way I do all of this is I created files, navigation, mapping, and planning. Each one of those implement a dedicated class. In the case of the mapping node, I have the setup where I initialize the GPS and the compass and the lidar, and then in the update routine I copy and pasted everything that the while loop has been doing previously, which is basically reading the laser scanner and then turning it into map coordinates and drawing the map. Now here I have a little problem. The chair is in the way, and I encourage you to remove all the chairs after mapping. This is a slightly difficult environment because you have only legs, so the maps are not really great, and convolving them too much will get you problems in this narrow passageway. So I think it's fine for this exercise to just remove the chairs once you have done the mapping. Alright, so now the robot is going back. It has planned another path. Now, how does it do that? When you look into the behavior tree, I compute the path, I use the blackboard, and I pass the goal node as a coordinate here, and then I do the navigation. Now let's go into navigation. I use the initialize function that is called whenever that node is restarting, and I do read the waypoints from the breakboard, and then in the update a routine I essentially copy and pasted what we've done previously. Alright, that's it. Now the robot is going back again. It already has a map. Just one more small detail here. There's something I've done. I set the memory of the selector to be true. That is another feature of the PyTrees library. What this means is that the behavior tree will always jump back to the last running node. If I remove this statement and also remove the map file from the disk, the robot will keep saying map doesn't exist because it will always execute the does map exist node at every time and then enter the parallel node. So again, if you don't want this, you can say memory is true. This works for all of the nodes in the sequence, and all of them have similar features, and set it to true. Now when I restart this, it will say map does not exist only once, and then immediately go into this parallel node and execute mapping and navigation in parallel. One additional detail you need to know is the terminate function of the PyTrees library is called every time the node is being used in your program. That means even if you don't do mapping, the class will get instantiated, and once you end your program, all the instances will get terminated. So what I've done is I have a function, or I have a variable called hasRun that I set to true whenever the mapping routine is actually running, and only then I do save the map to disk. Otherwise there is no map and I don't have to save anything, and I have to avoid an error message this way. So when what is run, like the terminate or the initialize versus the init and the setup, is something that is best found out in practice. And with that, I let you implement your peer review.